And we're live. What is this, Lady Ada?
Hey everybody, and welcome to another weekly show and tell. This is the video that we do every single week, live from the Adafruit factory. Me, Lady Ada, and Mr. Lady Ada over here. And this is where you, the viewer, the maker, the hacker, blacker, code cracker, out there can show us your cool projects, your hacker spaces, your wearables, your electronics, your lathes, and 3D printers, and whatever else you're working on, your retro technology, your emulators, your robots. Come on by and just, it's all chill. We just want to see what you're working on. Give us a demo, and super fast, super easy. If it's in progress, maybe it's done, maybe you're just planning it. It's all good. We have up to 10 people, and we'll get started. We'll call on people in the order we see them down here. We'll start with the Adafruit team members, and then we'll go on to other people. So just mute your mic, hang tight, and take it away, Tony.
Hey, yeah. So I've been doing some Python stuff on the Raspberry Pi. So maybe last year or so, went through and did a bunch of Python libraries for some of the popular Arduino sensors and things we have. You know, stuff like temperature sensors, the THT sensors. So we got a bunch of stuff on GitHub, and check out like the Adafruit Learning System to see those tutorials. But there's still a lot of other sensors that we have, and even some older legacy Python code. So I'm going through all that legacy code and like integrating a bunch of polls and things. That it's awesome that people have sent us a bunch of requests. It's been a little tough to keep up, but we'll get those kind of things integrated. And so I've just been playing with the MCP 3008, which is an analog to digital converter. It's a little hard to see. It's this tiny little chip kind of in the middle next to the Pi cobbler. And it's a real nice little ADC. It's 10-bit ADC, so it's the same as an Arduino. You know, not the most accurate thing in the world, but the big thing with the Pi is that it has no analog digital converter. And this thing is like, I think, $1.75, or it's a super cheap little chip, little DIP processor, so it's or a DIP chip form factor, so you can use it on a breadboard really easily. And you wire it up, and you can just talk using the SPI bus to the Raspberry Pi. And I'll switch real quick, and I'll just show a demo. So we have an example library already, and it's in the old Adafruit Raspberry Pi Python code. And so what I'm doing is I'm taking that, and I'm going to make it its own standalone library. And the advantage of that is that we can put it on the Python package index, so you can do like a little pip install Adafruit MCP 3008, and that'll pull it down. So it's a little bit easier, because the way all the code is right now, it's all in one Git repository, so it's a little tough to manage, and you can't put it onto like the Python package index. So hoping to fix that. And I will share the screen real quick and see if I can just show the little demo here. Okay, let's see. Let me know. Do you see the screen?
Yeah.
Okay, cool. So on the left, I'm connecting my Raspberry Pi here, and I'll run a little script that's running this simple test. And so this is outputting the value that it's reading from channel 0. And I just have a little potentiometer hooked up to it. So if I turn it all the way up, it goes up to 1023. And if I turn it all the way down, then it goes down to 0. So you can kind of see the range of analog values that it's reading here. It works really well. Real simple little chip to use. On the right, this is the example code that's kind of driving it. So it's real simple and straightforward. Like you literally just call a read ADC function, and that'll pull down the value for it. So hopefully it should be easy. And the real nice thing is eventually this will be like a single little pip install command to get this library down and start using it. So that's kind of what I've been up to.
Awesome. Yeah, thank you so much for taking on that work. We did a whole bunch of Raspberry Pi stuff about 4 years ago when the Pi came out.
Yeah.
And I can get things done, but it's not always the most elegant way. So I put everything into one repository, because at the time I was like, well, you know, like this is all I'm going to do. I didn't realize the Raspberry Pi was going to take off so much. You know, I used Python 2. I mixed tabs and spaces. I had dogs and cats living together. It was just a party. But
well, you know, the other thing is in the last few years since Pi came out, a lot more people have decided to take up Python.
Yep.
Yeah, totally. So this will make it a little bit easier to start using it.
Yeah. So and also things have stabilized a little more. So thank you, Tony D. It's good. It's well loved and respected that you are taking on this cleanup task.
Okay, we got a full house tonight. So
yeah, we do. Let's keep moving on.
No, Pedro, Adafruit South. East, what you got going on?
Yeah, so a couple months ago we showed off a little sample of a project. It's a Pip-Boy with the Raspberry Pi. So finally, I've finished it. I am wearing it, and I'm not trying to.
This is the new Apple Watch that's coming out on March 15th.
It's the new Windows Watch. It's a little bit bigger. Let me show you guys a little overhead view of it. It's pretty massive. It's like the most intricate Pi case I've designed yet, but it's pretty cool. So it's running Pi game. It's called Pip-Boy. It's on GitHub, and shout out to Greaves in Sabas 1080 who wrote it. And Tony D actually helped me get this knob to work with it, so it's pretty neat. So you can switch to different things. And oh, I just made it go completely white. But it's pretty neat. It's got a lot of different things in it. The battery's right here. It's a 2200 milliamp. You can recharge the battery if you need to use the power boost. It does have a speaker and an amplifier, a mono one, so that's kind of cool. It's all in there. And kind of to take it off, put it on, we have some magnets in the back there, so that's always nice. So you can quickly take it off and on. And is the audio still running? Can you hear that? it's like the background music from Fallout 4, so that's kind of cool. So this is going to be tomorrow's project. So
that's awesome.
Yeah, we're gonna play the video tonight. Oh, you cut out. Oh, there you are. Okay.
All right, awesome project.
All right, thank you so much. I know that was a monumental build. Are you gonna wear it while you play Fallout?
Oh no, and then they cut out.
They're frozen. They're frozen in time. Okay.
Hey.
All right. Let's keep going. All right, Phil B, how's it going?
Hello, it goes good. Thanks. Sorry I was late. It was trouble getting in here, but it seems to work now.
You're early.
So yeah. Anyway, guide I just published a couple days ago. Here on my laptop, I am running. I'm showing Jurassic Park in a window, the arbitrary movie, whatever. And over here on this, oh, it's totally blinding here, but it is streaming the video in real time to a dot star LED disc using processing and a bunch of code we wrote. It doesn't have to be the disc though. I mean, these things can come in all different shapes. You know, matrices. You could even use the dot star strips, and it's an interesting thing for I think art installations. The fact that you no longer have wires to the wall, or you know, you're not limited by the processing power of a microcontroller. Now it can stream data off your powerful laptop or desktop machine and blind you with that. Don't know if you can see it there, but it is showing Jurassic Park on the disc.
There's some motion. Can you show the back of it?
Yeah, this one I built using that's an Arduino Zero on there. But much smaller, the little 8x8 grid is using the Feather M0 Wi-Fi, which, there it is. You can't even find it on the back. It's so tiny.
Yeah.
But that's all integrated with the battery, the processor, and everything. And you're streaming video or animation off your computer.
Okay. I think it's awesome. Check out the tutorial, and we'll talk about it also. But, yeah, the idea, I mean, actually, not even knowing what's on the disc, it looks kind of neat because it's like moving around, but streaming live LED video is cool.
And what was the name that you came up with this, so everyone knows?
Lightship, yes.
Yeah. Second place, Sugar Plum.
Yes. Oh yeah. No, we played around with
Sugar Plum. I thought that would be a thing. Lightship's better.
It's a light ship.
It's a light ship. It's better.
It's a light ship.
I called it that. I love Close Encounters is one of my favorite movies, and I just
this means something. This.
Yeah, it just sounded cool. I thought.
Okay. All right, thanks, Adafruiters.
Oh no, we had a guest that was going to come in and say something.
Okay.
And they're gone now.
Okay, well, they'll come back.
Okay. We are going to go with Philip with one L. Oh no, two L's. You're 2L like me. Okay, good.
Other Philip.
All right.
Hey guys, can you hear me?
Yeah,
that's great.
Okay. I have the DIY monitor kits that I bought.
Oh, neat.
10-inch, and I bought this case at a local hobby shop. It was all plain. It's supposed to be like sort of like a jewelry box, maybe. I don't know. But I mounted the screen inside of it. You can see the control board, and it's got a perfect spot to store the Raspberry. So I use it as a Raspberry monitor. Currently, I've got it hooked up to my laptop, which is where you're all at right now.
I love it. It's got a real cool feel to it. It's a little treasure box.
Yeah, I've done it kind of like a steampunk look. I've got number buttons up here to control the monitor.
Oh, neat.
You can see that. They're kind of the steampunk thing look to it. And the other thing, since I'm trying to get into more electronics and don't have a space to it, if you see behind me, it's a big white room. This is my new 14 by 28 workshop that I'm currently building, so I can work on this stuff.
Oh, that's great. Are those Ethernet cables coming out, or is it other?
Yeah, there's about 19 of them there.
Okay.
Wow.
I'm not gonna ask any more questions.
All right. No, I was like, you're making your room as you're making in your room.
We're doing some wiring. There's a lot of Ethernet cables.
Yeah.
Well, thank you so much. The only thing that box is missing is as seen on the show and tell sticker. So email support@adafruit.com, and we'll send you a sticker for that.
And sorry, what was the dimensions of your workshop again? So I didn't get one.
15 by 28.
15 by 28. Okay. Cool.
All right. Next up, because I had emailed with Monica in advance to make sure she got here. Hey, Monica, how's it going? Oh.
Monica Houston.
Monica,
Austin?
you there? You were there, and then you're gone. All right. Well, Monica, if you can see and hear us, try to make it back.
All right, let's move on.
Okay, Richard.
Richard.
She's there, and then she's not there. She's there, not there. All right, Richard, how's it going? We're not able to hear you, Richard. Uh-oh.
Oh.
You want us to come back to you? Yeah, I'll come back to you. Okay, we're gonna keep moving along. All right, Gray Spy. Gray Spy, how's it going? Unmute your mic and show us your project.
Hey, Gray
Hello. Can you guys hear me?
Yeah, you sound great.
Okay. So I've just been working on a small, kind of sort of arcade game over the past few days with a particle photon and an OLED screen.
Yeah.
And I actually use the Adafruit OLED library to program it.
Cool.
So yeah, just something small that I've been working on.
All right. Can you hold it up again? I just wanted to see the game. So it's a little chip shooter.
And what you can do is you can move the player left and right.
Oh, that's cool.
And as you can see, you lose. It's a little hard to play since I can't exactly see it, but yeah, I also have a.
And you programmed it with a Photon. So does it use Wi-Fi or internet somehow, or you just program?
Yes, it connects to the internet, and then it runs the program.
Okay.
Wow,
cool.
That's a really cool project. When you're all finished, if you post any photos or do any documentation, let us know. But for now, you get an as seen on the show and tell sticker that would probably fit on the breadboard.
Yeah, it'll definitely fit.
Good work.
Great.
That's an excellent project.
Nice work.
Okay, we're going to try again, Monica.
Monica.
How's it going? Unmute your mic and tell us about your giant event that you're working on.
Great. Okay, hi guys.
Hi.
So I'm with Hackster, and Hackster is right now working on Hackster Live. So we're getting meetup ambassadors to run meetups all around the world. We have right now ambassadors in Zimbabwe, Nigeria, Serbia, Colombia, Mexico. We're looking for a lot more people, actually, probably 50 more ambassadors this year. And I run a meetup in Seattle. My colleague runs a meetup here in San Francisco. They're hardware meetups, and so there's a lot of networking meetups, and we want to run something sort of different where people can come. We have soldering irons and maybe some 3D printers and some hardware that we bring to every meetup so that people can come and bring a project and hack on it and eat some snacks. We call it Hacks and Snacks. So we're looking for Hacks and Snacks, yeah. We're looking for people to run meetups, ambassadors, and also if there's a meetup chapter in your city, you can check it out. Hackster.io/live is the URL. So you should go check it out.
Yeah, you should go check it out. All right, thanks, Monica.
Okay. And Adafruit is a sponsor, and by that we're allowing Hackster folks to purchase Adafruit stuff at reseller discounts. So if you can coordinate a Hackster meetup or something, they can probably pass that discount to you. So if you wanted to have Adafruit stuff there, that's an easy way to do it. We do that with hacker spaces. The word hacker is kind of fixed now. It was kind of broken for a while. I think we've repaired it.
Nice work, everybody.
Yeah. So if you want to have your hacker space have a discount, contact us if you want to have a Hackster event, Hackster Live event with Adafruit stuff. How do they get a hold of someone at Hackster, Monica, if they want to do one of these things that you said?
So you can actually contact me. My email address is monica@hackster.io. Okay. And on the webpage, if you go through the application, that'll go right to me. So those are all on my desk. Yeah.
All right. Well, thank you so much.
Thanks, guys.
Thanks, Monica.
All right. We're going to go back to Richard now.
Hey, Richard.
So his microphone's dead.
We still can't hear you.
No microphone for you. Do you want to do maker charades? Let's do it. Let's do it. I'm ready.
Okay, that's cool. This is an LED gas mask with like neopixels. It probably uses your LED Diva thing
because you 3D print parts of it.
You worked at it. It looks cool. Can you put it on? I mean, like we can't hear you. Whoa!
Yeah,
whoa! What's going on?
There's a movie.
This is a unicorn outfit It's really glam.
Is that live or is that a video that?
No, that's right next to him.
That's right next to you.
That's the thing. It's right behind him.
Oh, it's right behind you. Oh, okay, I see.
Yeah.
Oh, wow, that's weird. All right.
Yeah, that's kind of cool. So it's got the scarf. That
it's up there. Oh, okay, yeah, I see. It's because he's sitting
and
down.
This is an awesome outfit. This is perfect for Burning Man, or like a bar mitzvah.
Yeah.
One or the other, basically.
All right.
Great.
Well,
I hope next time you wear this.
Outstanding. When it's all finished, or even before, if you have any photos of it in action with people, send it to us.
Yeah, there's like a kilt or something going on. There's like straps. There's a gigantic zipper. You like gigantic zippers.
Yeah, I'm mostly made out of zippers right now.
It's mostly zippers. Nice zipper.
That is
zipper.
A nice zipper.
Yeah, it's a nice zipper. We're gonna steal that zipper from you. So watch out.
That was a zipper I was looking for a long time.
Yes, the zipper.
Can you email me and tell me where you got that zipper from too? Okay. All right.
There's a long story. Went to a hacker event. There was this hacker. There's a hacker who had this really cool jacket with a gigantic zipper, but he refused to tell us where he got it.
Yeah. All right. Let's keep.
He wasn't cool, and that's why you guys saved the word hacker, because he was a hacker, but now we're sharing information about sources, not hiding them.
Yeah. All right. So let's go to Ian. And how's it going?
Hey guys. So a while back, I showed off a parametric mold for a soft robotic adapter, basically.
Yeah.
Now, continuing with the parametric soft robots and stuff, I have this little thing, which is a mold for a bending actuator. Let me just, if I can, screen share with you.
Parametric bend actuator. Like, write down these words.
Ah, there we go. So,
okay.
As you can see here, this is in Thingiverse Customizer. I can change different dimensions and stuff. So give it a longer length, which is also the height, so I can make it really long if I want, or really wide. So that's kind of just that. And then one other quick. And then also here's the finished casted one.
Oh yeah.
Oh. There you go.
That's cool. The customizer was, they launched it with mostly customizing like iPhone cases.
Yeah.
So I'm glad to see that you're finding an additional use for it.
Making customizable robots.
Yeah.
And then another cool thing I'm doing is I'm collaborating with a guy who's building a pick-and-place robot for solving jigsaw puzzles.
Great.
And he wanted me to custom make him like little silicone nozzles. So, if you can see here, it could kind of hold it in place with suction right there.
Yeah. So he's going to do the software, and it'll pick up each piece and place it using vision and stuff?
I believe that is the plan. He has a little vacuum pump, and then he's just going to hook it up with some tubing and have it pick up little puzzle pieces.
All right, that sounds great. Actually, you know, I think it's probably more relaxing and fun to watch a pick-and-place robot solve a puzzle than to actually solve the puzzle yourself. So
yeah, it's just like any CNC machine is like hypnotizing to watch. So
yeah,
or if it's building a puzzle, it's even more so.
Okay.
Another job taken away from people.
So they're taking our puzzle gerbs. But what would be interesting is, you know, there's the robot. Rubik's Cube robot solvers. So I wonder if, like, eventually we'll be like, well, we already did that. Like, it's so dumb. The next thing is jigsaw puzzle solvers.
Yeah.
All right. Cool.
Okay. Thank you, Richard. I found the giant zippers, by the way.
Great. All right. Good work with the zippers.
Aiden. Email support@adafruit.com and we'll send you an SC on the show and tell sticker. All right. We're gonna go to Roberto and then we're gonna be outie for this week. How's it going, Roberto?
Hey, Roberto.
Going good. Can y'all hear me? Okay.
Yeah, you sound great.
Okay, I'm gonna share screen one with y'all and just show y'all kind of the beginnings of how what I'm trying to show came about. So, do y'all see my palm holding up a little coin?
Yeah.
So this is from what I showed off last time. It has those customizable cutouts. And when I was working on this project, I needed a way to verify when I made a change in OpenSCAD that it wasn't affecting other files. So for instance, in this one I have a spur, but the spur is also used in like a ring project I have. And so when I made a change to the spur, I needed to make sure it didn't, you know, affect the ring and this coin. So I ended up coming up with some bash scripts that became a test suite to let me take a photo, or I'm sorry, a generated still of the STL, and then I would use that as a baseline, and then rerun the test suite, and then get like a proposed baseline, and then compare the two to see if any changes had occurred. Like that, I would know if I'm affecting things in other parts of the library. So I ended up coming with utilities like find all the old SCAD, OpenSCAD files, generate baselines. But then I wanted to use this test suite for another project because this stuff was for the ornaments and the rings and stuff. And so I was working on another project. There was going to be an attachment for a slip ring. And so I wanted to use that same functionality, but when I tried to take the .sh scripts there, it wouldn't work. And I know it was just a few, like piping to the processes correctly away from getting it working correctly. But, my day job is working as a Java programmer, and I had the algorithm set up for porting. And so I ended up porting it to Java and having this project set up. And basically it's the same thing, generate a list of files that are available for processing and generate the PNGs for them. And so because Java, I'm more familiar in Java, I'm able to create basically in parallel a top, bottom, left, and right view. Instead of before, I was just creating a front view. And so this is kind of what it looks like. So like this is the bottom view, and I'm making sure that the proposed baseline looks like the original, and the same thing with the left and the right. And so, so I built that test suite to make sure that the attachment for the slip ring is working correctly. And so these are my iterations. Like, so here it was too small, and here, kind of there, and Cinderella story until I got it just right. And I'm making sure that I'm, like, if I make this longer, this piece longer, I want to make sure I'm not making the radius of the attachment longer. So that was the whole purpose of the thing. So now I have a basic attachment for this slip ring, and I can add on to the project and rerun the test suite, knowing that I haven't affected other parts of it. And the main part of this is because I haven't perfected, learning parametric designs yet, and so I needed a way to verify without going through manually verifying with my eyeball.
That's cool. That'll save you 3D printing time. And
yeah.
I like this idea of like you take a snapshot, almost literally, and then compare the snapshot.
Yeah. So like I need to make sure that these, the bottom baseline and the proposed bottom baseline are the same. And if I see any difference, the test suite will report that and say, hey, these don't match, and you need to go back and see what you changed.
All right. Awesome. Thank you for showing off your project. This is useful. Tools for tools for tools.
Thank you, everyone. All participants of the show and tell will get an SCN on the show and tell sticker. Please email support@adafruit.com, and we'll send you out a sticker. Thank you, Tony. Thank you, Roberta. Thank you, Richard. Thank you, Philip. Thank you, Phil. Thank you, Pedro. No, thank you, Monica. Thank you, Grace By, and thank you, Aiden. Don't forget, we're doing stuff with hackster.io/live. So you can sign up, become an ambassador, all that and more.
Yay!
And
go out and share making.
Yeah, if you like doing this virtual thing, occasionally you might have to see people in person. Good way to do it. Okay. All right, we'll see everyone on Show and Tell in a few minutes. We have a lot of Philip market share tonight. I just want to point that out.
That's good. Yeah, we have three out of 10.
I just want to point out, it's pretty rare. I actually never had 3 Philips in this
Good fill. Yeah. Good fill.
It's good.
Full of fills.
It's good stuff.
The 2L variety, too.
Yeah. No, we're
this is pure fill here.
Good.
Yeah. All right. Well, thank you, everyone, and we'll see you on Show and Tell
Real
in
fills.
3 minutes. Yeah.
True fills.
All the fills.
Bye.